All right, is this on? Yes, great. Hi everybody, my name is Franziska Heintel. I work for the Ethereum Foundation, mainly in the Solidity team, and today I'm going to talk to you about safer contract interactions for humans and how we can actually get there. So let's get started. But before we dive right into the topic, I want to ask you a question. Do you remember this title page of The Economist? It's probably 4 years ago, or like quite some time ago, The Economist put out this newspaper and called blockchain the trust machine. And this is what I want to challenge with you today in this talk. Are blockchains trust machines? Is the way how we currently interact with blockchains a trustless way or a trusted way? And what can we do to improve it? So first question, can blockchains be trust machines? Absolutely yes. If they are designed in the right way, so that's why I put maybe. But should we blindly trust blockchain applications just because we think blockchains are trust machines? Absolutely no. I mean, actually this is a no-brainer, but what we're seeing right now is that everybody trusts them and everybody just uses them without actually verifying, is this a trust minimized setup? So yeah, how can we achieve trust minimized interactions with dapps? This is what we will talk about today. You might be wondering, why this weird title? Why does she say for humans? That's because we all know blockchains have a lot of various different opportunities how they can be used, and some of them might be machine to machine or bot to bot. And that's not what we will focus on today, because machines speak different languages than humans do. And today, from the UX perspective, I want to talk about how can we make this safer for humans and how can we translate it into a language that humans can understand. Yeah, and also a friendly reminder on the side, I know this might be a surprise for some of you, but not all humans are developers. In fact, only 0.3% of the world's population are developers. So when we talk about UX, we should talk about a language that also non-technical people can understand. Okay, so what we learned so far is don't trust anyone, but currently really how? I mean, if you used any Web3 application in the last 1 year, or even last 3 years, doesn't even matter, you might have encountered something that looks like this, or like this. These are actually 2 screenshots from MetaMask right here. They show me hex data, 196 bytes, 900 bytes. Great. I have actually no idea what I'm doing, and this is why in the Sourcify team we used to call this process YOLO signing. You only live once signing, because actually you have no idea what you're doing. You trust the app that it will do what you want it to do, but you're not sure. This process can be also compared to basically driving on the highway with a blindfold on. We all do it today. Here are a few more examples. I'm not doing this to blame a particular project or to blame MetaMask. This is a systemic problem, so it has nothing to do, like, in that sense, in how they set it up. I'm just using these screenshots to make a point. Here, for example, I can't even use the application before I sign a message. And the message is, I mean, let's have a look at the message. This is a nice message, right? I mean, would you sign this? Do you understand what that means? I for sure don't. But the issue is I don't find out anything else about the dApp before I sign this message. And that shouldn't be the case. Second example, really, really amazing app, ENS. We probably all know it. Here I, for example, wanted to prolong my ENS domain for 1 year. I see what I want to do in the web interface, but once it pops up in MetaMask, all I can see is hex data 332 bytes. I mean, in this case, at least I see the function type renew. But that's really all the information I get, and I don't think that is enough for us to call it a trust minimized setup. I can actually not verify anything in there. Okay, so we see the trust issues are big, they are there. And if some of you attended ECC last year and watched Chris Reitwiesner, my colleague's talk, you might remember this slide. I put a screenshot here. There's lots of different trust issues when we try to interact with dApps, and my argument is basically I want to take this even one step further. for non-developers, it is even harder. Because as a non-developer, I would not even ask myself the question, do I call the correct function? I mean, as a non-technical person, I am like, what the fuck is the function, right? So the only thing that I'm really asking myself is this thing doing right now what I want it to do? Did anybody who knows more about this check it? And also, can I consider it safe to use? Yeah, the good news are there is a way to make this all better. The bad news is it is a bit more complicated than we would have wanted to be. But yeah, let's have a look at that. So how can we achieve trust-minimized interactions? There's basically two very important components that go hand in hand. One is source verification and one is code commenting. And I'm going to explain both of you today because I'm not sure who is more a technical person or more a non-technical person. So source verification is basically in blockchain the process in which you verify that the source code that has been transformed into bytecode and then has been deployed to the blockchain is actually the source code that the dApp developers open sourced and that you think you are using, yeah? So here we are talking about bytecode reproducibility. That is very important because we want to know what we are using and whether the code is malicious or not, right? The second point is code commenting. This is especially relevant for user-facing functions, which means that basically when dApp developers are developing an app, they should add comments to this function and explain what it does. Because if we have this information, which is also called NatSpec, that's a special format to do this commenting, then we could, in the next step, display it in wallets and in interfaces so that people actually know what they are doing and don't encounter hex strings. So yeah, here it's shown in emoji equations. Basically, there's only one way how this thing can work, and this is when we combine these two elements that I just described before. Because in any other case, the solution is very suboptimal. Let's look at the first one. The code is verified and open source, but the end user does not understand it. That's basically the example I just did in the beginning. That's bad, because I really have no idea what I'm doing. The second case could also be, I get some sort of human-readable information in the wallet. Maybe they display some sort of translation from the hex data. But the code isn't verified and it's not open source, so I can really not know whether this description that gets shown to me is accurate. That is also very bad, maybe even more dangerous. So yeah, in the end, only one thing works, and that is when the code is verified and open source and end users can understand it. That would be awesome. So yeah, let's see how do we get there. Meet Sourcify. Sourcify is a project that has been initiated roughly 1.5 years ago by Chris Reitwiesner and roughly the Solidity team. And it's first and foremost a decentralized metadata and source code repository. We support several efforts to foster adoption of open source verification, as you might have noticed before. We promote the usage of metadata files and NatSpec comments. Both of these things I'm going to explain later. And you can consider this a base layer, which will allow other tools to basically make use of the data that Sourcify stores, and also where other tools can be built on top of. But also that will be explained later. And yeah, the main purpose for the more technical people in this room is to keep metadata and source files available via IPFS and prevent that the links in the bytecode turn into dead links. So what the heck is a metadata file? I hope the dApp developers under you know what it is, but I will briefly explain it. Basically, in Solidity version 0.4.x, very long time ago, a feature was introduced that is called metadata file or metadata JSON. And basically what it does is that at the end of the bytecode is the part that gets compiled when you write Solidity and then you compile it, then the result is a bytecode. So at the end of this bytecode you find a hash, and it shows you, or hex data that shows you the used compiler version and a swarm or IPFS hash. And if you follow that link, you can find a lot of things that are very important for what we're talking about. The full compiler version, complete ABI of the contract, developer documentation, user documentation, also called NatSpec, and the compiler settings to recompile the code to the bytecode. Yeah, unfortunately, right now, the power of these metadata files is still not leveraged, And that is why I'm standing here and trying to spread the word about it. What is NatSpec? NatSpec is basically a form of code commenting. It's short for Ethereum Natural Language Specification Format, and that means it provides rich documentation for functions, return variables, and more in the form of comments. And that can be categorized in developer-focused comments and end-user-focused messages. And especially today, focusing on the end-user-focused messages, they are crucial to users since they are the part of the information that, in the example in the beginning, could be displayed in the wallet so that I actually know what I'm doing instead of looking at hex strings. Yeah, you can see an example of how that could look like here. So basically, on the left, we see again the hex data, and on the right, we see how this could look like. We would see what function type it is, what arguments it has. So in this example, we want to again renew an ENS domain, and we see the name of the ENS domain. We can confirm the duration. We see basically what the description of this function interaction is. And even better, we also see that the source code and metadata files have been verified on Sourcify. And if I would click on a link here, I would probably see some sort of contract repository where I could even look at the source myself if I'm a developer. So that would be a much more informed decision that I could take here in terms of, do I really want to interact in this way or not? Okay, so how do we get there, and what does Sourcify currently do to help us get there? The biggest part of Sourcify is currently an automatic monitoring and verifier service. That is actually a super handy thing, because right now developers, if they want to verify their code, they have to go to Etherscan or to other services, and they have to upload all their source files, and it's sometimes a very long and annoying process. And this automated monitoring and verifier service, what it does is basically it listens to the blockchain and to newly produced blocks. It checks in the blocks whether new contracts have been deployed, and if yes, then it follows this hash that is in the bytecode to find the metadata, and then to basically make sure that this metadata doesn't get lost on IPFS. And then the next point, the contract repository, basically puts all these files in the contract repository, including the metadata, like the ABI. And yeah, then the data is safe, doesn't get lost, and wallets or other tools could use it. And that all actually without the developer needing to do anything under certain circumstances. But you can also manually verify your contracts. For example, you deployed a contract before Sourcify was out there, or maybe you didn't have your source code published, so Sourcify couldn't find it. In these cases, you can use the manual verification interface, or also one of the several verification plugins that are out there in IDEs like Remix and Hardhat. Also, at this point, a huge shout out to the community contributors that also help us with this. It's not only the core project, but we really have an awesome community as well who supports us. And lastly, there's a fetcher, which means you can, as a user or a curious person, input the contract address and check whether this contract has been verified, and if yes, it will again lead you to the contract repository. Yeah, if you have seen last year's talk, you might be wondering, okay, it's been a year, what have the guys been up to? Is there anything new? Actually, there's a lot of new stuff. We had a complete UI revamp. We are actually even working on a new iteration right now. We have added support for many more chains. Of course, we support Ethereum and all Ethereum testnets, but additionally to that, also added support for Celo, Avalanche, Binance, Polygon, you name it. We have more plugins and integrations now, like Hardhat, Remix, Block Scout. We have a CLI, creation code database, support for libraries and immutables, and the option to reuse existing files. If you have no clue what that means, then don't worry, because then it doesn't really affect you. Okay. Yeah, sorry that this GIF is so blurry, but this is basically a little video of how you can use the manual verification interface to verify your code. And in this example, basically all I did was input a contract address to check whether it has been verified. And it showed me in the beginning, yeah, so basically I choose the chain here, I input the contract address, I click verify without uploading files, because I just want to know whether it has been verified. Okay, it has been verified, amazing. So I click on the repository link, and I see it has been a full match which means also metadata is available, and I can see all the data in the contract repository. That sounds amazing, right? Problem is, we cannot do it alone. We have built it as it stands right now, but actually we need the whole ecosystem to work together on this to make this a reality and to actually have the end users benefit from this. Before I rant about what the ecosystem should do, I want to give some shout outs to very great initiatives that are already now and today working towards safer contract interactions. We have a Block Scout integration where basically you can already see whether contracts have been verified if you click on the code tab. There's amazing hardware wallet called Keystone Wallet, which actually leverages the 60K contracts that are in the Sourcify repository to already today display this information that I just showed you on the MetaMask screenshots. So basically, in this example, you could already today see way more human-readable information before you have to sign a transaction, because they make use of the metadata files that are in the source in the repository of Sourcify. And then also other amazing initiatives. Grid Plus has been endlessly working on how to making contract interactions more safe, and DAppNode has been thinking with us about how we can decentralize the Sourcify service more. Okay, so let's look at what people can do to bring this to everybody. Firstly, what can Dapp developers do? Very easy and straightforward. Use NatSpec to comment your code. So this means for all end-user facing functions, write there in the NatSpec format, if possible, what the function does in human-readable language. Then secondly, use auto-publishing, which basically means every time you deploy a contract, the source files and the metadata files get uploaded to IPFS automatically. And yeah, lastly, verify your code, which means upload your source code files and metadata files, for example, using Sourcify. But in the very best case, it gets already caught by the automated verifier service, and you have to do nothing, but that only when all the files are available. Okay, what can the broader ecosystem do? There's lots of stuff actually. Deployment tools and IDEs shall encourage auto-publishing that I've described before, or even make it the default. I think we are all open source enthusiasts here, and people that do not want their code to be open source, they should go the extra step and disable whatever auto-publishing function. Wallets can display human-readable contract information by making use of basically ABI and sources that are, for example, available in the Sourcify repository. The ecosystem can help to expand NatSpec. That's the format that I've talked about before. It's currently not perfectly specified, and yeah, we would really appreciate the ecosystem to jump in here to give us feedback and to even help expand the specification format further, and also give wallets confidence to actually display this human-readable information of the NatSpec. So basically by verifying it via services like Sourcify, block explorers can add Sourcify support, and organizations can help host the data because it's growing quite big and we want to stay decentralized. And yeah, for what users can do, I really only have one question, but it's or one ask. It's a very simple ask, and yeah, I really ask you all to shout it from the mountains: do not use unverified code. It's as easy as that. Yeah, I actually stole a flowchart here from Nick. I made you a flowchart. Have they published and verified the source code of their contracts? I added on Sourcify. Yes, maybe use them, because you guys know we can never be sure. It's not a guarantee for everything. No, definitely do not use them. And that's right now, unfortunately, not the case. So please go out there, educate, and also follow the best practices yourself. What should you take home from this talk? No matter whether you are a dev or a user, always verify your contracts, or always check if they have been verified, and also, even more important, demand verification. So if you bump into an app and you realize they haven't verified their code, tweet at them, go to their support channel. If you know somebody from the developers, talk to them and tell them, hey, your code is not verified, I'm not going to use this unless it has been verified. Yeah, raise awareness for the safety risks, because otherwise we will never get there. And for the more technical people, pin the Sourcify content on IPFS, join us in the calls. We have a weekly call. You can contribute code if you like, and yeah, generally help us decentralize Sourcify. Yeah, with that, I'm already almost at the end of my talk. Let's stay in touch. We have a website. It's sourcify.dev, or in the Web3, sourcify.eth. We are on GitHub. We are on Twitter at sourcify.eth, and I'm on Twitter at Franziska. And you can join the conversation in Discord or Gitter. They are bridged, and you will find the Discord invite in the pinned message of our Twitter. And last but not least, a huge shout out and thanks and credit to Chris, Edi, Fabian, Jakov, and Ligi. They are the ones with the vision. They are the ones who built Sourcify. I'm only the messenger today. And yeah, big thank you and applause to you guys. I'm not sure if we have time for questions. Okay.
Thanks a lot for the talk. In the GIF where you showed the verification process, you upload the smart contract containing the NatSpec comments. So it's clear how you check the smart contract versus the bytecode on-chain, but how do you ensure that the NatSpec comments are genuine?
Do you mean how the verification works?
Yeah, especially of the NatSpec.
Yeah, the NatSpec is part of the metadata file, as far as I know. So you can basically, when you recompile everything, that should be included. But I'm not technical, so maybe you ask the guys that sit here in the front. Oh, Jakov, do you want to respond? 1 second. Somebody will give you an answer.
Hi, I don't know who I'm answering to. Yeah. You can never be sure that the developer didn't write something misleading in the NatSpec, but we can only verify that that code was published and deployed. So there's that. Thanks
a lot. Yeah, I forgot about that, but now I remember it myself. Basically, that's why open source is so important, because we assume that everybody is open source, it's out there in the wild, other people can see it, so you could basically call them out. But yeah, it relies on basically the developer network to work together and somebody actually looking at it. Other questions?
Hi, I was wondering if Sourcify would work for other languages than Solidity. Say if one day there was something that replaced Solidity for Ethereum.
I mean, Solidity, Sourcify in general is like a project that is bigger than just the components that I've mentioned so far. So I think at its core is the effort to really raise awareness in terms of open source verification and code commenting. So Sourcify will always be there for other languages as well. Right now in this recompilation process and automatic verification process, we only support Solidity. But with my minor technical understanding, I would guess we could also support other languages. But yeah, that's not planned or on the pipeline in the near future, as far as I know.
Yeah, hi. Thanks for your talk. So I liked one of the examples which involved the ZK layer, so layer 2 in your example, so showing that it's hard to verify what they do. And I think that in the future we might have a lot more of those layers happening with hashes, basically that you have to validate which are parameters of another transaction. So is there a way to deal with that with Sourcify, like linking several transactions together or describing that a parameter is a hash of something else? Or is there a way to basically make those kind of boxes and linking stuff together?
I'm not sure if I understand the question correctly.
Okay. We can talk later.
Yeah. So basically, we added support for side chains that are like layer 2 solutions. So that is already there, but I'm not sure what you mean with the linking parameters.
I just have a small suggestion. It seemed like in the demo, you have to drop files, right? Why can't you just put like a Git repo on it to speed up the process, so that way I don't have to download and then, right, you just give the URL and that's it?
Yeah, I'm not sure if we were thinking about that already, but yeah, I see thumbs up. So yeah, we can think about that. Okay, seems like there are no more questions. Thank you, guys.